So the following scheme of reactions state the type of structural isomerism shown by propanal and propanone. So that one's fairly straightforward. That's going to be functional group isomerization. And then identify, so a chemical test can be used to distinguish between samples of propanal and propanone. So remember that's an aldehyde and this is a ketone. Identify a suitable reagent. So there's three possibilities here. So I'm going to pick Tollens, and we'd have a silver precipitate with propanal and no observable change with Tollens reagent, but we could use Failing solution. So use Failing solution, which will give you a brick red precipitate, just kind of abbreviating it as I talk through, and then again no observable change here. I could use acidified potassium dichromate, and here I would see orange to green, and again no observable change here. So I'm just kind of putting those in as alternative answers. Okay. Part C, state the structural feature of propanal and propanone, which can be identified for their infrared spectra by absorptions at approximately 1720. You may find it helpful to refer to the data sheet. Just check this on the data sheet, but this is screaming at you that this is the carbonyl. D, the reaction of chlorine with propane is similar to the reaction of chlorine with methane. So the type of mechanism then is going to be free radical substitution. And then write an equation for each of the following steps in the mechanism to form. So you see where the chlorine is here. I need to make sure that my dots go on there. So the initiation step is going to be that. My chlorine radical is going to react with propane, CH3, CH2, CH3. Never do these as molecular formulas. And that's going to give me CH3, CH2, CH2, and I'm going to put my dot on there as I've outlined up here, plus HCl, and this is going to start my second propagation step with my dot on that carbon there, with chlorine that didn't undergo the homolytic fission, which gives me CH3, CH2, CH2Cl plus Cl dot. So a termination step to form the molecule with an empirical formula of C3H7. The big clue here is there's no halogen in here whatsoever. It wants the two of these that react together. So CH3, CH2, CH2 dot plus, and you can do this as 2 if you wish, but sometimes it gets a bit, sometimes the structures are difficult to work out. My advice here is to draw it where the dots are facing each other, and then you almost do dot to dot. So you'll see what I mean if I kind of do it on this one. There's one dot there, with the dot there. So my product is where I join those two there, and then obviously I have to rub out my kind of dots there. So, and although there's 6 carbons there, it does have the empirical formula of C3H7. So again, I can tidy this up and do a 2 there if I wish, but the structures are quite complex sometimes, and it is easier to do it that way. Okay, E. So high resolution mass spectrometer of a sample of propane indicated that it was contaminated with traces of carbon dioxide. Use the data in the table to show how precise MR values can prove that the sample contains both of these gases. Okay, so what I need to do is for propane, C3H8 and carbon dioxide, CO2, I need to work out the precise MRs of these. So for propane, that works out at 44.06352, and for carbon dioxide it is 43.0 43.98982. So there's 1 mark for that, and it says, so this is to prove that the sample contains both of these gases. So you would need to state on top of this that you would see 2 peaks, one at 44.06352 and one at 43.98982 for the molecular ions. Okay, and the mark scheme doesn't need the values written out again here, but you do need to mention that you'll get 2 peaks, one for each of the 2 molecular ions.